Okay, so let's look at this question together. Question 4, I'm going to read through it. A man of mass 85 kilograms runs up a flight of stairs of height 4.6 meters in a time of 12 seconds. So the first thing to recognize is that we're going to use two equations here. The equations we're looking for are power is work divided by time here, and work equals mass times gravity times distance traveled. And so luckily the units there, kilograms, are already in the correct unit. Meters is also the correct unit, and seconds is the correct unit. So there's no unit conversion that needs to occur. Okay, so we're going to, for question A, calculate the man's power rating, which we're going to say is the same thing as the man's power. We're going to put these figures through the first equation and then into the second equation. So that's just simply going to equal to 85 times 10 times 4.6 when we sub those figures in, giving 3,910 joules. And then taking that figure and subbing it into the second question, power equals work divided by time, we're going to do 3,910 divided by 12, and then we end up with a power of 325 watts, which is the answer. For the question B, we're going to have to do a little bit more work, and this is a little bit more tricky. So that's why I'm making this video now. So the first part is that the girl in question achieves a power rating of 75% of the man's power rating. And for those of you that know anything about maths, that's not too challenging. You would basically do 70 divided by 100 times by the figure here, 325, would give you 75% of, is like saying 75% times. So when we do that, we come up with a figure of 228 watts. Now, where this gets a little bit harder is calculating the mass of the girl. Okay, so to do this, we're going to have to amalgamate both equations together, and so that's what and then we're going to have to rearrange them, and so that really is a bit more challenging. So let's try and amalgamate the equation. So what I'm going to do there, I'm going to write power equals work over time. So work, instead of writing work there, I'm going to write mg times g times d, and they're all going to be multiplied together, and then we divided that by t, which is the time. And so you can see what I've done there. I've just taken this figure here and placed it into this equation here. Now, why have I done that? I've done that because the question is asking for mass, and the mass is here, and I need to get mass on its own in the equation. And this is where the algebra gets a little bit complex, but if you remember what I've said already, the basic principle we're going to use is whatever you do to one side of the equation, you're going to do to the other in order to cancel down. Okay, so first thing I'm going to do is try and get rid of that t. I'm going to times t on the top there. I'm going to do the same thing here. Whoops. I'm going to do the same thing here. Okay, t times p. And as I've done that to both sides, that's t divided by t is 1. Times anything by 1, it disappears. And I've got rid of t. What I need to do next to rearrange, well, I want mass on its own, so I want to get rid of g and d from this side. So I'm going to g times d on there. Divide sign there, g times d on there. This cancels through to 1 and disappears. So I now have t times p divided by g times d equals the mass. So I've rearranged the equation to make mass the subject. What I've got to do now is sub the numbers in. So looking through, I can see the time, t, 9.6. I'm going to go down here and do this. I'm going to do 9.6 times the power, which we've just worked out, 228, divided by G times D. Well, G is always 10 on Earth. It's not always 10 actually, it can be 9.98. In this equation it's given us, in this question it's given us 10 times by the mass of the girl, and so that's going to be, sorry, the height, and that's going to be 4.6, no different to what the man did. Okay, and that is going to equal the mass of the girl. Okay, so when we stick all that into our calculator, we come out with the answer as 47.6 kilograms, which is a reasonable sort of mass for a girl, and that's it.